In this section, we'll start talking about what are known as infinite series. And infinite series will pretty much guide us through most of what we do in this chapter. There's a little bit of things that are different in the very end, but that will be the majority of the content here. So we need to get comfortable with exactly what is meant by an infinite series. So definition here, an infinite series is a sum of infinitely many terms and written in the form, this is the Greek letter sigma, capital Greek letter sigma, all right? N equals 1 is the starting point for the series, and infinity is the ending point. A sub n is a function, and we plug integer values of n into this function, whatever it happens to be, and that gives us the terms of the sequence. Then we take the terms of that sequence and add them all together, and that's what makes a series. All right, so just keep in mind this is your starting value of your sum, and this is the ending value. All right, and also make sure you get used to the fact that the symbol capital Greek letter sigma means a sum of terms. And generally, students can wrap their heads around a sum that's finite. Like for instance, if you have a finite number of terms, like if you just want to know what's the sum of the integers from 1 to 15, you can certainly get that. But if you ask what the sum of the integers is from 1 to infinity, well, that presents a problem, because if you continue to add larger and larger values, you're going to get a larger and larger number. So under most circumstances, that sum would just be infinity. But as we saw with integrals, and integrals are a type of sum, we saw under the right conditions, you can actually have an integral that converges to an infinite integral, that converges to a real number, and likewise we can have an infinite sum that converges to a real number. And we're going to look at the conditions as to when that can occur. So most of the time we'll be dealing with whether a series converges or diverges. All right, and it converges if the sum happens to be a real number, and it diverges if that sum goes to positive or negative infinity. Now, one thing that has to be true is that in order for a series to converge, the terms of the sequence must be going to 0. And you want to make sure you really separate the ideas of what is a sequence versus what is a series, because if you start mixing up those ideas in your head, then a lot of the questions, which are supposed to be different, might start looking the same. So the sequence are the individual terms, and the series is the sum of all those terms added together. All right, so the series is really going to be just one number in the end. Now, it should make sense that if you are going to have an infinite series that converges, your sequence terms have to be going to 0. Because if your sequence terms get larger and larger and larger, or even stay constant, then what's going to happen is you'll be adding more and more value to the overall sum with each iteration, which would never converge. But if the values of the sequence are going to 0, you're adding a lesser and lesser and lesser amount, which might actually have a chance at convergence. And that concept is wrapped up in a rule that's called the divergence test. Sometimes it's also referred to as the nth term test, but I think the divergence test is a good name for it. And it states that if the limit as n goes to infinity of some sequence is not 0, then the series of those sequence terms diverges. That's all there is to it. All right, so be careful, because this is a necessary condition. So the limit of n going to infinity of a sub n equaling 0 has to happen, but it doesn't tell you that it will converge if it does happen. So there are sequences where the terms of the sequence go to 0, but yet the sum still does not converge. So don't only use it for divergence. Don't use it to prove convergence, okay? All right, so let's say we have a series, n over the natural log of n from 1 to infinity. We're going to show that this diverges. Now, the way to do this is to present the evidence for the test and show what the result of the test is. So, for instance, we need to show for the divergence test that the limit of these sequence terms is not 0. So we need to show, whoops, I need a pen, not a highlighter, that the limit as n goes to infinity of n over the natural log of n is not equal to 0. How do we do that? Well, we have L'Hopital's rule at our disposal, and it's going to get used a lot in this chapter, so make sure you review it if you don't remember it. One thing that is specified in L'Hopital's rule is you have to have a limit that's of the type 0 over 0 or infinity over infinity for it to apply. So you can't just use L'Hopital's rule willy-nilly. But when you let n go to infinity, of course n, the numerator here, is going to infinity. And the natural log of n, it does go to infinity, albeit a lot slower, but that's okay. So this is of the type infinity over infinity, so I am able to use L'Hopital's rule, which says to reevaluate the limit, but take the derivative of the numerator and denominator. So the derivative of n is just 1, the derivative of ln of n is 1 divided by n. So then this becomes the limit as n goes to infinity of n, and that right there has a limit that's infinite, because as n goes to infinity, n goes to infinity. It's hard to argue that. So that gives us the evidence for this test. Okay, that's an important part of your problem. Okay. Then you want to state your conclusion. All right, so your conclusion here is that the series going from n equals 1 to infinity of n over the natural log of n diverges by the divergence test. All right, so stating that it diverges, that's the result. And then also we have the test used. So the thing I want you to understand and know here is that when you do your homework, there's going to be a lot of questions where you get a problem and you check a box that says converges or diverges. And you can very readily go through that homework set checking converges, diverges, and when you get it wrong, you can switch it and then get it right. That's not the point, because when it comes to test time, you have to state the result that you got, the test that you used, and then present the evidence of that test. So you might want to make sure you're getting into the habit with your homework of providing all of that, because you'll absolutely need to provide it on your test. Just simply writing converges or diverges without any supporting evidence will absolutely get you a 0 on those questions. So just kind of make sure you understand what's expected of you.